Section 1.2, Slope of a line, vertical intercept, and rate of change. Our goals for this section will be to calculate the slope of a line through 2 points, graph a line using a point and the slope, learn how to use the slope-intercept form of the equation of a line, and interpret the slope as a rate of change. So first, the slope of a line. So here we see a line passing through 2 points, which I call x1, y1, and x2, y2. To determine the slope of the line, what we can do is create a right triangle that connects those 2 points. And so what we have is the vertical distance between the 2 points, which we call the rise of the line, and the horizontal distance between the points, which we call the run of the line. The rise and the run are also often called delta y and delta x, respectively. So this symbol is delta. So then the slope of the non-vertical line passing through the distinct points x1, y1 and x2, y2 is given by slope, which we often abbreviate as m, is equal to delta y over delta x, the rise over the run, and we can also write that as y2 minus y1 over x2 minus x1. This is frequently called the slope formula. So here's a couple of examples. Let's determine the slope of the line passing through the following points. In our first example, we have the points -5, -3, and 5, 17. Then the slope m would be equal to 17 subtract -3 over 5 subtract -5, which simplifies as 20 over 10, which is 2. So we say that the slope of this line passing through those points is 2. Notice that that's a positive value. And just really quick, if we were to get a very rough sketch of these points, -5, -3 might be here, and 5, 17 might be way up here. And if we drew the line through those points, one thing I want you to notice is that those points, the line rises from left to right. Let's see another example. Here we have the points 1/2, -3, and 3, 3. So then using the slope formula, the slope would be given by 3 subtract -3 over 3 subtract 1/2, which simplifies as 6 over 5 halves. Now 6 divided by 5 halves, when we divide by a fraction, that's equivalent to multiplying by its reciprocal. So that's 6 times 2/5, or 12/5. So the slope of the line is 12/5. And again, if we were to draw a rough sketch of these points and connect them, let's see. 1/2 -3 might be down here, and 3, 3 would be up here. And again, notice we have a line that is increasing from left to right. And in fact, every line with a positive slope will rise from left to right. So what can we say about the slopes of these lines? Notice how this first line increases, it rises from left to right. This line has positive slope. Contrast that with the line to its right. Notice how this line falls from left to right. Any line that falls from left to right has negative slope. The third line, which is on the bottom left, does not rise or fall. This is a horizontal line. And if we think of the slope formula, notice that since it doesn't rise, its delta y would be 0. And so our slope would be 0 over some number. I'll just call it a for any number. And 0 over a is 0. Horizontal line, any horizontal line, has slope of 0. In our final example, we have a vertical line. And again, if we think about the slope formula, now notice that the line is vertical, and so it has no delta x. All right, so the change in x is 0, and so we have some number over 0, and that's an undefined expression. And so a vertical line has undefined slope. Now let's learn how to use the slope along with a point to sketch a line. Alright, so here we're asked to sketch the graph of the line that has the given point and slope. We're told it has the point 2, 4 and the slope negative 2/3. Let's assume a standard scale here. So each mark will mean 1 unit, so I'm going out to 5 units in either direction. The first thing that we'll do is plot the given point. So we plot the point 2, 4. Now we know that the slope is negative 2/3. So we know that since the slope is negative, the line is falling from left to right. Now let's actually use the numerical values. Since our slope is negative 2/3, I'm going to think of that as a negative 2 over a positive 3. And since that's my rise and my run, my delta y and my delta x, from that given point, the line has a delta y of negative 2. The line falls, or 2 units, and then the delta x is 3. The line runs 3 units. And so using that, I can plot another point on the line, and I can continue to do that repeatedly. So from that point, the line falls 2 and runs 3. Now I could have also thought of the slope as being 2 over negative 3, since a positive divided by a negative is still negative. And so now taking 2 as my delta y and negative 3 as my delta x, the line rises 2 units and moves to the left 3 units. And again, I get another point on the line. So there's a few points on the line. And so now, using a straight edge, I will draw the line that passes through those points. And so there is the line defined by that information. The slope-intercept form of the equation of a line is an important form that we need to be aware of. And this form is denoted by y equals mx plus b, where m is the slope of the line and 0b is the y-intercept of the line. That's the point where the line crosses the y-axis. So now let's learn how to use that slope-intercept form. Here we're asked to graph equations. We have the equation y equals 3/4 x minus 2 and y equals 4 plus 1/3 x. I'll work in blue for the first equation. And let's again assume just a standard scale on the axes. y equals 3/4 x minus 2 is in slope-intercept form. So I can immediately identify that the slope of this line is 3/4, and that the vertical intercept, the y-intercept, is the ordered pair 0, -2. I now have a point and the slope of the line. So I'll plot the point 0, -2, and I'll use the slope 3/4 to let the line, remember that's delta y over delta x, let the line rise 3 units, 1, 2, 3, and run 1, 2, 3, 4 units, and I can plot another point on the line. Similarly, I'll let the slope repeat. So again, up 3 and right 4. And then I will draw the line passing through those points using a straight edge. I'll work in orange for the second equation. Y equals 4 plus 1/3 x. Well, I can change the order of the terms and write that as 1/3 x plus 4. So then my slope for the line is 1/3, and the y-intercept is 0, 4. Again, I will plot the point 0, 4, and using the slope of 1/3 to let the line rise 1 and run 3, and I'll let that repeat a couple times. Drawing the line that passes through the points using a straight edge. So there's a couple examples of how we can graph linear equations in slope-intercept form using the slope and the y-intercept. Another skill we want to be able to have is to take an equation, a linear equation, in different forms and be able to rewrite the equation in slope-intercept form. So recall that the slope-intercept form is y equals mx plus b. So generally what we want to do is to get in a linear equation in slope-intercept form, we want to isolate the y variable. So if we look at this first example, 2x plus 3y equals 6, I'm going to isolate the y variable. And to do that, I will first remove the other term from that side of the equation, yielding 3y is equal to -2x plus 6. Thinking ahead of what we want, that mx plus b form, I'm going to put the x term first on the right-hand side. And now to isolate y, I will divide the left-hand side by 3, and using really the distributive property, divide each term by 3, yielding y equals -2/3 x plus 2. Here's another example. 5x minus y over 7 is equal to 2. Again, I want to isolate the y variable, so I will first remove the x term from the left-hand side, yielding -y over 7 is equal to -5x plus 2. Now, the y variable is being divided by 7, but I could think, since it's a negative in front, I could really put that negative in the denominator. And so now to isolate the y variable, to undo that division by -7, I will multiply by -7 on both sides of the equation, yielding y equals, and applying the distributive property, 35x minus 14. Earlier, we talked about how to sketch an equation that was in slope-intercept form. Now let's turn it around. Now let's find the equation of the line in slope-intercept form, and here we have this line. Alright, so generally what I want to do here is to try and find two good points on the line. Fortunately, it appears that we have a very strong y-intercept at 0, 20. And now I just need to find some other point. Here's a good point. So we have another point at 40, 50. So now I can calculate the slope. M would equal 50 subtract 20 over 40 subtract 0, which is 30 over 40, or 3/4, or if you want a decimal, 0.75. So we have the slope, we have the y-intercept, we can write the equation. Y equals 3/4 x plus 20. And we'll finish off this section with an application. Here we have a graph that represents the cost, C, in dollars, of renting a vacation villa in terms of D days. All right, so we have the cost in terms of the number of days. We're asked to first find the slope and explain its meaning in the context of the problem. All right, so let's find the slope. I'm going to use the points 0, 200, and 1, 300. Now, finding the slope, m would equal 300 minus 200 over 1 minus 0. Now, what were the units on these numbers? Let's see. The cost in dollars, so the y values, these are dollars. D, the x values, the horizontal values, are days. So 300 minus 200, these are dollars, days. So we have $100, 1 day. Now, we usually abbreviate that. 100 divided by 1 is 100, and so I would write the slope as, let me move up here, $100 per day. So, find the slope and explain its meaning in the context of the problem. All right, we found the slope. So here's what it means. The total cost for the villa increases at a rate of $100 per day. Write the slope-intercept form of this line. Well, we know the slope is 100, and we know the y-intercept. We found that earlier. The y-intercept was 0, 200. So we can write the slope-intercept form as, well, we're not going to use y and x. C is equal to 100 d plus 200. All right, so we again have this graph, and we're asked a few other questions. But let's recall that we found earlier that the cost was equal to 100 d plus 200. Exercise C asks us to identify and explain the meaning of the vertical intercept. All right, so the vertical intercept again was 0, 200. What is the meaning of that? What could the vertical intercept mean? So if we think of it in terms of an ordered pair here, that means 0 days the cost is $200. How could that make sense? Well, sometimes when you rent a vacation home, there's maybe a down payment or some other payment, some other defined cost for things like cleaning or other maintenance. And so then we often have that cost and an additional daily cost. Now we know the daily cost is $100 per day. So what I'm going to say here is there is some fixed down payment of $200 for renting the villa. Exercise D asks us, from the graph, determine the cost to rent the villa for 5 days. All right, so from the graph, so we go to where D equals 5. D equals 5, and we move up the graph to the point, and we see that that point is 5,700. So my conclusion, the cost for renting the villa for 5 days is $700. And exercise E asks us, again from the graph, determine the number of days the villa was rented if the cost was $400. So now we want C to equal 400. So go to where C is equal to 400 and move to the line and find the corresponding point. And so that point is 2, 400. So if the total cost was $400, then the villa was rented for 2 days. All right, that concludes the presentation for section 1.2.